Hey everybody, this is Tavi and Alex from Dashboard. Welcome to the Operational Excellence and Large-Scale Serverless Application Monitoring webinar. Uh, Today will be a bit of an advanced topic. It will be talking to the people who are already using serverless, perhaps at scale, or are scaling their, or in the process of scaling their applications. I think it's going to be quite exciting. The things that we are talking about today is like the culmination of learnings from the past 3 years that we have worked with serverless users, and yeah, really excited to share what we have found out and how we're thinking about this problem with you. Um, Throughout this webinar, you can submit questions into the YouTube commentary box. We will answer all the questions at the very end, so I will not stop my presentation or Alex in between when you ask questions, but at the end we will have a kind of a Q&A, and we will answer all the questions and discuss things that you feel that we should discuss more. So let's get started. I will start with my speech. I'm going to fade Alex out for now. Alex will be back in like 20 minutes. So today I will be talking about operational excellence for large-scale serverless applications. So this is first a quick intro again into myself. I am the CEO and co-founder of Dashboard. I've been a developer myself for over 10 years. I worked with serverless since quite early on, since 2016. I've built pretty large-scale serverless infrastructures before founding Dashboard, and that's what led me to found such a company as well. So really happy to share kind of my thinking around these subjects. Today, what we will be covering is kind of the end-to-end journey that starts from understanding the challenges and kind of mapping them out. Like, if you're running a kind of if you're just starting out with serverless, we're gonna talk about what you might expect when you scale and go into like larger workloads, and you start to have more users and kind of more load on the application. We'll talk about coming up with monitoring and operational strategy, how to assess risks and how to identify areas where you should be focusing the most, kind of what's really important, what's not as important. Then the third part will be around the effective infrastructure to actually monitor and secure and operating production infrastructures. So the second one will be more around the strategy. The third one will be around actually implementing a monitoring practice and security practices for your serverless application. And the last bit will be kind of understanding and defending against known and unknown failures, and kind of how to think about catching and detecting issues as they arise, and how to also defend against them, how to react, and what that should look in a company. So let's start with kind of an intro into the challenge. The thing with serverless is that historically, when we had containerized environments, we were looking at like maximum 5 to 10 to 20 servers. All the logic was contained there, and like all you had to do was attach an agent that would monitor what your endpoints were doing, how the resource usage was, but it was quite straightforward. So with serverless, you end up with hundreds or even thousands of resources, and usually those resources, or like cloud resources, are on the spectrum of the managed services. So they could be functions or managed databases, managed queues, S3 buckets, API gateways. I'm sure you all know the different kinds of services. But with that, the complexity actually grows. So you have, let's say, like 500 resources across 10 different services, and that's quite a challenge to actually operate in production where you need to rely on this. And I think the number one learning is, from my experience, the sooner you kind of address this and identify that this is a problem and start trying to solve it, the better it is for you. So if you kind of scale yourself into an environment with thousands of resources, it's going to be a pretty difficult problem to challenge at that point. So let's look at just to give you a mind model. This could be a serverless environment. It's not even that big. I think this has less than 40 functions and I think over 10 databases. So this is basically not as big, but it still presents a lot of challenges. Just when you look at it, like all those small parts can actually fail in a lot of different ways. So if you break down the challenge a bit more, then there's actually two things. The first one is the amount of data and the amount of know-how that you have to develop for monitoring serverless applications. So, the 50 functions actually mean that you have 350 different metric data points. Not 50 functions, but you have 350 things to monitor. And you have like gigabytes of logs. You have millions of tracing data points. So that's really hard to visualize and really hard to comprehend. And I think one of the biggest challenges also that we see is for engineers to develop deep know-how of those services. So, what are the ways that a DynamoDB table can actually fail? I'm sure a lot of people know, but there are a lot of different services with a lot of different scenarios in how they can fail, and identifying those and understanding those and constantly monitoring for those is a big challenge. Which brings us to the next kind of the second biggest challenge is the variety of actually the failure scenarios. So even if you look at your infrastructure, you can probably map out a couple of ways that it could fail, but in reality, something unexpected can still happen because there are so many different ways that you can end up having an issue in your infrastructure. So for Lambdas, that means timeouts, code exceptions, running out of memory, hitting concurrency limits, things like that. For API gateways, you can wrongly configure them. They can also have timeouts. Some other issues for queues, databases, you're looking at delays, throughput limits, misconfigurations. So a lot of moving parts, a lot of different challenges, and it grows exponentially as you scale your infrastructure. I want to take a step back and talk about this thing called observability, which has been thrown around a lot lately. So it's a really interesting concept, actually, if you think about it. It means that you can tell the internal state of a system just by looking at the external outputs of that system. So the theory is that in the case of managed services, you do not need to interfere with the system itself. All you need to do is look at the data that it puts out, and then you can understand the state of that system, and then you can identify failures, you can visualize the activity, and you can do everything with that. The data is already there. I think the problem is that data is in silos and it's really hard to work with, and there's massive amounts of that data. So for a human, going through logs, going through metrics, access logs, configurations, tracing data is a huge overhead, and you're not going to be able to do that as a human being really well. But the data is already there, and I think that's one of the key things that enables you to achieve this in the end, is that actually there is all of that data already available. It's the matter of putting that data into use and really kind of building a solution that works for you. So, knowing all that, let's move into the kind of monitoring strategy side, and kind of how you should be thinking about operational practices and monitoring for your organization, and what kind of you should set as the goals really. So for monitoring, it's quite straightforward. The main thing is that you need to have confidence to quickly build and iterate products with minimal risk, so you can make deployments as frequently as you can, and if something happens, you will know. So the number one thing to kind of defend against is the mean time to discovery. So if you have an API endpoint that's failing, or if you have a configuration error somewhere, it's critical to know about it as soon as possible, and that is the biggest lever that you can pull for your monitoring strategy. Google's SRE handbook says that over 70% of all use cases for monitoring software starts with alert that something is wrong, and that's the overwhelming majority of the use cases is based on when an alert comes into the system, and then a developer starts reacting into that. So reducing the mean time is really important. Other thing that's really important is enabling developers to be more efficient and giving them the ability to focus on customers, not on operational stuff. So that's a really big kind of advantage as well, or a competitive advantage, if you're able to kind of make your developers more effective and be more confident with their infrastructure. I think the fourth, but a bit overlooked thing, is that your operational and monitoring strategy needs you to enable learning from mistakes over time. So if you make mistakes, if you have incidents, you need to have a framework where you can write those things down, document them, and do retrospectives and learn and kind of get better, learn to preempt more things, expect more things, and over time, the quality of your service will improve if you do that. So when you start when that's clear, what we usually do, the next step is risk mapping. So what are the requirements for the system, really? Like, how fast does it need to be? What's the expected uptime, and how much can it cost? Important to note here that usually the response time, uptime, and costs are dependent on each other. So if you need quicker response time, if you need more a higher percentage of uptime, it's going to cost you more as well. So it's good to kind of have a really clear understanding of what those should be early on. What's the acceptable time to discover failures and to react to them should be agreed before. And yeah, so I would say figure those things out as early as possible as well, because that really helps. So when we kind of have those two things in mind and give it a little bit of thought, kind of the requirements for your monitoring and operational infrastructure or solution are actually quite straightforward. So you need an infrastructure or a platform to ingest, navigate, and interrogate vast amounts of monitoring data, and kind of to democratize the data from the silos. You need to detect failures as quickly as possible, and you need to debug or to have the ability to debug your system quickly and understand situations efficiently. So that's really, I would say, those are the three kind of parameters to grade your monitoring approach against. So let's jump into the requirements. And as the first thing, what's important in navigating and interrogating data. So now we're talking, if we're going to actually start tackling the challenge of monitoring, what we should be focusing on and what gives the biggest benefits to us. So in our experience and in serverless, the most important thing is breaking down silos between different data types, because that really enables you to see the bigger picture and to correlate metric events from log events and to understand why like either one of those are happening. So this could be like, for example, if you have a spike in your like error metrics in your functions, what's causing that? And then you can see that it's either timeouts or it could be like code exceptions or something like that. But it's important to kind of to correlate logs to metrics and then to tracing data to kind of drill down into deeper levels of the activity data that we have. In serverless especially, and in modern cloud environments, cross region and across multiple account visibility is extremely important. And we see a lot of customers struggling with that a lot as well. That's another kind of example of data being hard to navigate, hard to access, and in silos. So plan for that. Then kind of more kind of day-to-day or kind of like a straight approach is that you need to have the ability to look at data from different angles. So in some cases, dashboards are like really good. Email reports can be good, but you also might need to search or to query or to interrogate that data as efficiently as possible. So it doesn't just kind of do that you have the data, you need to be able to actually look at it from any angle. We find also important to have like different levels of data, which we'll go into more detail really soon. If you need to have account level view, service level view, resource level view, and transaction level views. So that we found really helps with debugging. And I think the critical thing, especially with serverless, is that your infrastructure is constantly changing, which means that you might be adding or removing cloud resources. Some resources might become more active over time. Others might be less active. So the kind of the platform that ingests that data needs to adapt and kind of automatically manage those situations so that you don't have to have the overhead of, kind of importing data yourself or configuring the data importing yourself. Or to even manage alarms as well. So that is really a lot of work and it can be overlooked easily. So in my experience, those kinds of parameters are the most important things when looking for a solution that you can monitor your cloud data. So a couple of I'm not going to spend too much time here, but just to go through the levels of data that you should be looking at and kind of what the meaning is for each of those levels. So if you look at account or microservice levels, your goal is to detect major problems and changes as early as possible and kind of continuously understand trends. So this could be health. The most concerning areas, like what are the main kind of erroneous areas, function the slowest parts, the most costly parts in your application, what's the overall cost, so you won't have any surprises, and kind of total activity. So if you have, like we have here, a trend downwards, kind of to be able to spot that and then to investigate further. Also, Alex will go into this a lot deeper, but here's another good example of visualizing an entire account in one picture. The second, or the third level actually, account, microservice, and resource is the resource level views. And I think those are one of the most important levels and kind of the area where developers spend most of their times. So if you're working with a cloud resource, if you're trying to understand what's going on, then that's really important to kind of be able to do that as efficiently as possible and to work with as much data as possible. Let's look at functions. So in functions, you would need to have access to the invocation metrics, error metrics, cold starts, memory usage, and the cost over time as a bare minimum. So if you take a look at those trends, analyze those trends, then you can understand how code changes or any kind of change to your system affects this over time, and if things have gotten better or worse, or what you should be paying your attention to. Another thing is anomalies. That becomes particularly interesting with large amounts of executions where a human cannot no longer kind of go through them. So if you have 1% of your executions that is taking way too long, you need to kind of have the ability to drill down into that to identify those executions, and then to go further, which we will talk in a second. Errors associated with that resource that have happened or are still happening, and kind of the best thing would be to have ways to improve and to align that resource to operational best practices as well. So if you have kind of from that data some things that are obvious that you should do, it would be good if that system would automatically run those checks. So not too much to advocate Dashboard, but this is how it looks in our system. We show you all the recent invocations. We detect the events that you should be kind of worried about or you should be paying attention to, and we graph out the changes of all the parameters over time. So just to kind of give a real-world sense of what's going on with this particular resource. Let's go into the execution level. So execution level is important when you have a problem that you're trying to understand, and you kind of need as much information as possible. So the basic stuff like duration, memory usage, start and end time are what everybody knows. You need logs. You need profile of the execution and what requests were made to other resources. So if you have a function, for example, that takes too much time, you would want to know where that time goes. And if you're perhaps querying a DynamoDB table or another function, then if that response was successful or not, and how long to detect took is critical. It's also good to detect retries and link those retries between invocations. So if you have an async pattern where, for example, consuming items from an SQS queue fails, then those would get retried, and it's good to have retries linked within each other. And another exception or another example of how it looks in Dashboard. On top of the levels, your infrastructure should have the ability to search, to query, and to bubble up. So you kind of, the alternative to looking at resources one by one or by service or by account is that something happened, but you don't know where, or you're kind of trying to interrogate a function that has sometimes a problem with cold starts or with latency or with any kind of other meaningful thing, and then to have the ability to actually find those invocations across a bunch of data is really important. So that's I think that with serverless becomes more important as well. We need automation, we need the ability to search and kind of access data as we like it. On to the last bit of my presentation is it's going to be 5 to 8 minutes. I think it's the most exciting part. So when you kind of have the infrastructure in place, the kind of number one goal should be to defend against known and unknown failures. Because in monitoring, the most important thing is to discover incidents as early as possible to be able to react. So if you don't know that something happened, that will have the biggest impact to your business. The problem is twofold. You need, as I mentioned before, you need deep understanding of the cloud services that you are using for each and every service, and that takes time to develop, and you kind of need to go through the buckets yourself to understand how to defend against those issues. And the other problem that we see is managing alert coverage. So if you have, if you have APIs, if you have Lambdas, you have databases, and each of those have criteria on like how long can they respond to you, what's the kind of accepted delay, what's the accepted cost, things like that. Then one thing is to set those alarms once. The other thing is to continuously set those alarms as the infrastructure changes, and to do that in a meaningful way. So let's go into an alerting strategy that you would then kind of deliver, or what should it look like? I think it all starts with defining expectations. Like you can call it an SLA, or you can just kind of write down on a piece of paper, like, what are your expectations to your application and what absolutely cannot happen, and what you deem as okay to happen as well. On the kind of high level, you have 3 things that you can do to react to things as quickly as possible. Filtering log events for events, failures, whatever can happen there. Monitoring metrics continuously, and running preemptive checks to kind of identify things, or try to identify things before they happen. Those can be related to security, posture, best practices, cost, and performance. So with logs, like there's a lot of examples here. Take Lambda, for example. Lambda automatically logs out all the code exceptions, all the timeouts, all the configuration errors. So all you need to do is set up filters for your log streams, and to catch them automatically. Dashboard does that automatically. As soon as you connect Dashboard, in 2 minutes you have alert coverage for all the log data coming in. You don't need to change any of the code, install any of the agent. It's already there and it works, and kind of you are protected for all the known and unknown failures that can happen. If you don't have Dashboard, there are ways to build it into CloudWatch log stream filtering. This requires work on the filters, and also requires work on the alerting itself. So you need to build integrations and kind of build that whole pipeline, which can be quite complex, and it poses the other challenge of having to maintain it if you add or remove functions over time. The other thing to note here is that Lambda isn't the only thing that's producing logs. You should have API gateway logs enabled. You can have multiple different services in AWS that actually all produce logs, and you should have you should monitor for the critical events for all of those from all of those logs actually. The other thing we see a lot is custom events. So the kind of the need for monitoring not just failures, but like some other custom events that happen in your system, and having the ability to get alerted for those events. We are actually working on that, but we don't yet support this. The next part is metric alarms, and I think that's where it gets a bit more trickier. So the kind of multiple problems here. The first is that there are just a lot of metrics that you kind of have, and how do you know even which ones to monitor and how to monitor them, and what are the kind of the right thresholds, for example. So our recommendation is to start with the customer-facing things. So if you have an API gateway that's connected to a function that goes to a database or like wherever, and then responds to the customer, you could monitor all of those downstream resources, and you should as well. But if you have a time constraint, you should be focusing on the API. And then if your API is like slower than you expected or has like error rates, then you still get an alarm, and then you can investigate further into what happened. So yeah, latency, error rates, service health, which can be a kind of a difference between how many successful and non-successful invocations have happened, for example. Also, going a step deeper, looking into leading indicators is important. High memory usage, increasing delays in like downstream services. Those kinds of things can really have like a cascading failure effect. And so it's really important to detect those early on. So a bit farther down the rabbit hole, we have cost monitoring, which depending on your system might be important, might not be important. You might not have a risk of accumulating a lot of cost, but sometimes there are a lot of risk for like depending on the service. So we recommend for some customers to set limits or like alerts to when the bill increases more than they expected. And I think the best advice anybody can give here is do it programmatically and centralize with other alerts. So in Dashboard, we also offer this. So you have the ability to automatically set those alarms, and then those would get propagated across services of your choosing. The fourth kind of level is what we call insights or actionable preemptive alerts or actionable insights. So this comes down to continuous management of risk and finding optimization opportunities. So the problem is that if you're changing stuff, if you're adding new services, your developers might forget or overlook some areas. Like, do you have encryption on your databases? Are your functions with the least privileged permissions? Are you detecting over-provisioned or redundant resources to save costs? And where could you improve? And overall following best practices. So you should have some sort of a programmatic and continuous way of checking for those kind of things, and fixing them as they happen as well. So that's also another area of our platform that we're starting to do, is to run continuously checks across your infrastructure to identify things that could be improved, and kind of overall reduce the risk of something happening to your infrastructure. So the last thing of your alerting strategy, but I think one of the most important ones, is to actually make a plan and practice incidents. So you should have a clear action plan when something goes wrong, and you should test this in staging environments, and do that with a frequency of once in a quarter, depending on the size of your infrastructure and kind of the risk as you see it. It's really important to document incidents and make retros, and kind of to learn from past experiences, and kind of to always strive to get better. And if you have SLAs, track your actual performance against those SLAs to understand where you lie, and how much work to have on your plate, and kind of what you should do to get better. So I think it's that kind of is where it all even begins, is to set expectations and to track how well you're performing against those goals. And then you understand if you have a problem or a challenge, or if you don't. In our experience, operational excellence takes a lot of time and effort. It is not something you kind of slap on a Band-Aid or adopt the service and then immediately you have it. With serverless especially, it's a kind of a new paradigm. A lot of developers aren't used to it. So, the things you can do today is read the AWS well-architected serverless white paper, and also the original that has, not just serverless, but kind of all the practices that you should be using as an organization. Also, I think the solutions architects of AWS and the serverless community is at your disposal. So there's a lot of forums, a lot of communities, that you can turn to if you have problems or like specific challenge. And I would recommend play around with third-party tools. So there's some of them on the market. The trials are free, and they are generally quite easy to actually onboard as well. And so you're not really risking anything, but it might help a lot. And so reminding you that you can ask questions, but